Falcon 9's booster completed 36 flights, saving over $1 billion in rebuilding costs. Rockets cost billions, used once waste vast sums. Global space agencies struggled for decades. Falcon 9 solved it. A 10-story column re-enters at Mach 6. Its shell reaches over 1,000 degrees C. It ignites engines, slows from 2,000 ms to zero, landing vertically. It succeeded 36 times with no failures, beyond the initial 10-flight design. Understanding rocket recovery shows it's far from just braking with engines. The difficulty, only one chance in final descent. Engineers call it suicide burn. It's called this by engineers during descent. Engineers call it suicide braking for the booster. With limited fuel and high thrust, the booster must ignite precisely seconds before touchdown. Speed must be zero now, else ignition too early burns fuel short or delay causes crash. Metal tons plunge, sparking fireball. Error margin less than a second in space. Atmosphere re-entry heats up. Thrusters aim for the carrier. 4 grid wings deploy, each with hydraulics for extreme heat. Millimeter adjustments. 3 ignitions. First, retro thrust slows from hypersonic. Re-entry ignition protects from heat. Final ignition for landing. Failure in any ignition ends recovery. SpaceX lost boosters 2013-2016. Some crashed into fires, others fell flat on landing. Over 10 boosters detonated. Some crashed, others fell as landing legs didn't lock. They stand briefly, then explode. SpaceX posts clips online. Title: How to blow up a rocket booster costs millions. Critics called it waste, but Falcon 9 landed its booster deck 2015. Falcon 9 landed on, of course, I Still Love You barge in Atlantic, April 8, 2016. Recovery became routine. Falcon 9 launches surged. Flights rose yearly. 26, 31, 61, reaching nearly 100 in 2023. Right, one rocket launches nearly 100 times yearly, unmatched in spaceflight history. Falcon 9 launches over 20 Starlinks at once. Starlink has over 6,000 satellites for global coverage. Starlink now orbits over 6,000 satellites worldwide. Constant launches keep satellites in orbit. Reusing boosters cuts costs. Booster flew 36 times. 9 Raptor engines ignite at liftoff. Total thrust, 770 tons, equals 7 Boeing 747s lifting together. Engine temp exceeds 3,300 degrees C. Exhaust gases exit at 10 times sound speed. Ascent lasts about 2.5 minutes. Booster separates at 80 km when fuel ends. It reverses, heads down, endures heat, ignites for landing. Repeated 36 times, this 8-minute process saw over 100 successful engine ignitions. Merlin 1D engines use liquid oxygen and RP-1 fuel for over 85 tons thrust. High-thrust 9 engines, 1 central 8 outer. High thrust-to-weight ratio, 9 engines at the bottom, 1 central 8 surrounding. This setup ensures mission success if any one engine fails mid-flight. It happened. A Falcon 9 delivered payload to orbit with 7 engines after 1 shutdown. Reusability cuts costs. Pre-Falcon 9 missions cost $150M to $350M. Falcon 9 cuts launch costs to $67M with reused boosters. It's $15M to $20M. Price shift transforms space market, now accessible beyond governments and militaries. Now, even commercial companies and university laboratories can purchase a launch slot. SpaceX secures over half of global launch orders yearly, offering best value and reliability. Falcon 9 isn't last. SpaceX tests Starship in Texas. This vehicle towers over the Falcon 9 at 120 meters, with 7,500 tons thrust. Much bigger than Falcon 9, over 120 tall with over 7,500 tons thrust. Largest rocket ever, built for full stage recovery. Star's success could cut launch costs under $5M. Sending a KG to space costs barely more than an Intel package domestically. Its most notable feat is flying 36 times. But rather that it proved a concept once deemed impossible by the entire industry, as long as someone keeps trying. It's now real. 10 years ago, rockets were sci-fi. Today, it happens every 3 or 4 days on this planet, and most people don't even bother to look up anymore.